Okay, so we're going to look at cosecant and secant. So we're going to start off by looking at what the parent function is. We're going to go back to our unit circle because cosecant is related to sine. Cosecant is 1 over sine, which in other words would be 1 over the y-coordinate on the unit circle. So the first one here at 0, the y-coordinate is 0. 1 over 0, we should know from doing tangent and cotangent that we're going to get undefined. At pi over 6, the x-coordinate, or the y-coordinate is 1/2. 1 over 1/2 is equal to 2. I'm going to keep filling these in. You can kind of catch up at the end and make sure your table looks like mine. So we're going to speed things up a little bit. Alright, just so you can see these a little bit closer up, I know it's a little blurry. We have undefined, 2, root 2, 2 root 3 over 3, 1, 2 root 3 over 3, root 2, they start repeating, you see. 2, undefined, -1, undefined. We started skipping some numbers down here. So now I'm going to show you what this looks like when we graph it. Now these values are a little bit hard to graph. We would need to use a calculator and get some decimals. Really, the easiest way of graphing cosecant and secant is to start off by graphing sine and cosine, and we'll see that those two graphs are closely related. So I'm just going to go ahead and plot the points I need for sine. I'm going to make a smooth curve. I'm starting off with pencil just in case. And then cosecant, we're going to have an asymptote right here. And we're going to have another asymptote here. So that could kind of help us answer this question when sine, or y, is equal to 0. We'll get our asymptotes. Another. There we go. There's all three. So cosecant, being the inverse of sine, kind of runs opposite. We're going to start off real high. Remember, asymptotes, now we're going to touch. The cosecant at pi over 2 is 1. And then we go back up towards our asymptotes. So we're going to get these U shapes. I'm going to get one underneath between pi and 2 pi, we're in the negatives. And then I could keep going with the pattern here. So here's a rough sketch of what the cosecant graph looks like. Cosecant is the inverse of sine. Secant is the inverse of cosine. So it's 1 over cosine or 1 over x. So I'm going to fill in this table. Make sure you get your table filled out. I'll zoom in a minute. And just so you can read over this, 1, 2 root 3 over 2, root 2, 2. Undefined, and then they start to repeat. 2, root 2, 2 root 3 over 2, -1. Oh, actually, all of these should be negative as well, because we're in to the... And then we have undefined and 1. So like cosecant, we're going to start off by graphing cosine and then make the u's on the tops and the bottoms instead of trying to figure out what all these decimals are. So when we start to graph secant, our first point is at 1, and then we're going to work our way up to 2 at pi over 3. And we have our asymptote at the zeros again. So we can answer this question down here at the bottom. Secant asymptotes will occur where cosine or the x-coordinate is equal to 0. And then we drop down to the negatives. And I'm going to finish up the graph. And there we have the secant graph, inverse of cosine. So let's go over some of this information, the domain and range, similar between the graphs, so we can kind of talk about them at the same time. The domain, we need to skip over the asymptotes like we did in tangent and cotangent. So the domain will be all except for, in this case, multiples of pi. And these will be the multiples of pi. The range, we notice there's actually a hole in here because the sine graph doesn't really appear in the cosecant graph, so we're going to say it's going to go from negative infinity to negative 1, and then we're going to close it, and it's going to go from positive 1 to positive infinity. So it's got 2 pieces to it. Similar at the bottom, just we're going to change where the asymptotes are. These are at multiples of pi over 2. Same range. We skip over that bit in the middle. Oh, and the period is going to be the same as the sine and cosine. So both of these are going to be 2 pi. So I'm going to fill this in really quickly. We know it's going to be very similar to sine and cosine because these are the inverses of those. So A in your additional notes, you might want to write out about how we graphed it using the sine and cosine graphs to start with, and don't forget to include the asymptotes when you think about the domain, and use the asymptotes to help you graph it.